Okay, so today we're just going to be looking at a simple little player controller script. It will work both for keyboard and mouse as well as for controllers. It's going to be not that much coding to actually do, and it should all be pretty easy to understand. So hopefully it's something you can take and use in basically most of your projects and modify it for however you see fit. So, to begin with, let's just let's just start by creating a scene. So, we're going to want, an object as our player. We'll just make that a cube. We're going to want a ground, so let's just make a plane. Drop the plane down to under the player. Let's scale it up a little bit. And let's make a texture for our ground. Because at the moment, if we move the player around, there's no texture on the ground, so we won't really be able to see the player moving relative to the ground. So let's just create a material. We'll call it tiled. And then we'll just give it the default checkers. If we chuck it on now, you'll see it's massive. So we'll fix that just by tiling our tile texture. And now we have a nice little ground. Cool. So we're basically ready to start trying to get our cube to move. Let's make a script, a C# script. We'll just call it movement. And then open this up in whatever your editor is. Yeah, so now here we are in our script. We'll just start off by adding some variables. So we're going to want to have a private rigid body. We'll just call this our RB. RB. And we're going to want to have a private float of speed, so that we can actually set this in the inspector. We're just going to come above and make it a serialized field, which basically just means it's private, so it can't be accessed by other scripts, but it can be accessed by the inspector. So if we just actually have a look at Unity and put our script on our cube, you'll see even though it's private, we do have it showing up here. Cool. Okay, so now our rigid body, we're just going to want to set that. So we get our rigid body, and we say it's equal to this dot get component. Then we're just finding the rigid body, and now this will be filled up with whatever rigid body we have in our object. Cool. So now we want to have some floats. So we'll have a float move H for move horizontal, and we'll have a float. Actually, we'll just do that one after. Yeah. So it's going to be equal to our input dot get axis, and the axis we're looking for is our horizontal axis. Now we can just copy this line, change this to vertical, vertical. Cool. So, what's this? Weird. Okay, don't need to worry about that. Now we have two floats. We have our move horizontal and our move vertical, which is basically going to be our horizontal and our vertical movement. And we're going to create a vector out of these. So we want to create a vector 3, and we'll call this vector 3 movement. And it's going to be equal to a new vector 3, which will have our move horizontal and our move vertical. I'm not used to this keyboard very much yet. It's a new laptop and it's all laid out weird around the arrow keys, and yeah, it really gets to me when I'm programming. Cool. So now we have our movement vector. Let's see, it's all weird up in this area. Okay, now we just want to get our rigid body, and we want to actually set our movement. So we're going to use add force. Oh my god, I need to get used to this. And yeah, so we're just going to be adding our movement, and we're going to be timesing it by time dot delta time, and then timesing that by our speed. And then because we are using physics, we want to be doing this in fixed update instead of update, so just fixed. And that means instead of running every frame, which is what update does, fixed update runs every 0.02 of a second, which means it runs 50 times a second, which is the same as how the physics updates, and basically it allows you to smoothly interact with the physics. Okay, so now with that we can just save and come over to Unity, and we're going to need to add a rigid body to our box, to our player, and we'll turn off gravity, we'll set some drag and our mass, and give it some speed. With gravity, you don't want to have it on all the time, you basically just want to turn it on when it's needed. So do something like have a raycast coming from the bottom of the player with a distance check, and when the distance is greater than it being on the ground, turn on gravity then. Otherwise it's just going to be affecting all your other forces and making everything kind of muddy feeling. So yeah, cool. So now if we press play, and I'll just pull out my phone. Okay, so you can see me moving with WASD, moving with the arrow keys, and then the cool one, moving with the controller. So we have all of that happening just from these few little lines here. And that's why I really like this method of going about your movement script, just because it's so minimal and it does so much, and it's so easy to edit and make it do anything you want it to. So with that in mind, let's add a little bit more functionality to it. So we'll bring our camera over here, pull it in a little bit, so it's centered on our cube, rotate it on our cube, and make it a child. So now wherever our cube moves, the camera will move, which we can actually just look at by coming back over and pressing play. And yeah, so now we have the camera moving along with our cube. But as you can see, as we move the mouse, nothing happens. And obviously, that's not ideal. So, to fix that, we come back into our script. Okay, so to get the camera controls, we are going to need to add a few more variables. So we'll come back up to the top, and let's just copy this, paste it again, and change this to our mouse speed. We're also going to want to have a private game object, and this is basically going to be our camera rotation on the x-axis, and then we're going to want to have two more private floats, one called x and the other y. Cool. So that's all the variables we're going to need. First off, we'll come and set our camera rotation on the x-axis. So that's going to be equal to our camera dot main dot game object. Cool. then we can come down and start doing some stuff in our actual logic. So we have the two floats we created, one being x and one being y. So x is going to be equal to our input, dot get axis. This all looks familiar, but this time we're going to get the mouse x, and we're going to times it by our mouse speed. And again, grab our y, and this is going to be our mouse y. Yeah, we won't put in that stuff yet. We'll just show this first. So transform dot Euler angles, which is basically our that's my parrot. It's basically our angle in degrees. So yeah, equals to a new vector 3, which is just going to be 0 x 0, and then our camera rotation, dot transform dot Euler angles equal to our new vector 3 Okay, so as I tried to explain the code just then, my parrot decided that she must talk very loud. So I'm going to do this again. But before we do that, there's actually a few little things I've noticed which should probably be changed. So camera rotation X, if you just come to that and right click and hit rename, we can rename all of them at once. Just camera rotation is a better name for that because it's actually doing all the camera rotations besides the X-axis. Then our X-axis, let's just rename that to our Y. We'll need to do it lowercase because otherwise it's going to conflict. Then our Y we'll rename to our X, because basically they were just swapped around from what they actually are in Unity, which doesn't matter at all, but it's a little bit confusing if you're going back and forth. And yeah, cool. So that makes more sense from like an analytical point of view. So let's just go over the code quickly and explain what it's doing. So the new code we just added, up here we've got our camera rotation, which is just a game object, which is storing our camera game object. We're caching it here because otherwise, if you're just referring to this in the update function, that's actually the same as just doing a search for a game object, which is pretty expensive to be doing every frame or 50 times a second. So instead, we just do it at the start, and then we have the reference. Okay, so I had to grab Ellie, the parrot, and hold her, because otherwise she's just wanting to talk. But here we have our Y, which is our float, and it's just equal to the mouse axis, which is something I'll show you in a second. But basically it's getting our mouse movement on the X-axis. Also, we just have it reversed basically, but that's why I had it named that way, which makes sense because we actually had it set to what the mouse is doing. But having it set up this way, it makes more sense. But yeah, so here we have our mouse movement, and then all we're doing is that we're grabbing our game object, which is our player, and we're setting its angle to a new vector 3, but we're only setting its Y, which basically means it will rotate around on the spot to face whichever direction the camera's facing. And then we're grabbing our camera, and we're setting its rotations to be equal to the same as the, well, basically, yeah, we're turning the camera and the player to face the same direction, and then with the camera we're also allowing it to pan up and down. So if we just save that, it'll make more sense if you just look at it. press play. Whoops. We'll also need to set a camera speed. So it's something like 2. And yeah, so now you can see it's moving with the mouse, and you can look up and down. But you can loop all the way around. And obviously we don't want to be able to do that. And that's actually something that's really easy to fix. So we'll fix that quickly. All we want to do is add a constraint. So we grab our x-axis and we just say it's equal to math.f or mathf dot clamp, which basically just means we're going to clamp the value. So we're going to clamp that value, and we're going to clamp it from -50 to 50. We'll just say they're floats just to make it clear. But yeah, so now this value can only go from -50 to 50. If it goes below -50, it will just stay at 50. If it goes above 50, it will just stay at 50. So if we save that and come back in, set our camera speed again because I did it in game mode. Now you'll see it gets clamped and we can't look beyond the clamp distance. But you'll notice if we move, we're just moving forwards in the direction of the game object's original forward, not the direction we're facing. That again is pretty simple to fix. All we want to do is come to our movement vector, and we just want to add our transform dot rotation, and we'll times that by our direction. So basically we're grabbing the direction of our rotation, and then we're adding our other player inputs on top of that, which then gives us our ultimate move vector. So if we come over and press play, again, I didn't set this when we weren't in play mode, so I need to do it again. But now, if we just hold down W, the player will move in the direction the camera is facing. Pretty simple. And yeah, basically with that, you have a complete basic player controller. Actually, that's not quite true. At the moment, the way it's set up, we don't have the mouse working with the controller. So to do that, we're going to have to come into our project settings and our input. And if you have a look in here, this is where we're getting our horizontal and our vertical and our mouse axes from. So we just want to duplicate these layers, which you can just do by Shift D. And now we have 2 of them. We'll edit the top ones by coming down and changing this to be joystick motion, and we'll collect it from the 4th axis. And then the top one of mouse Y will change to joystick, and the 5th. The reason we're doing that is because, as you can see here, make that picture bigger. Oh, that's not what we want. But yeah, that's how it's bound in Unity. So let's just see how that is at the moment. It might be the wrong ones. Set this to be 2. Cool, so let me just pull out my phone again. So yeah, now we have the movement on here as well as on our mouse. So yeah, basically all we did there is we've come into our input manager, and we've duplicated the mouse inputs, which get in input from the mouse, and we've created them for the Xbox joystick, which is I think the same as the PlayStation 1, and like just like generic gamepad, so it should work with most things. But because they have the same name, the code will read both of them because we're just looking for that name, so it can get input from either. So now you have a player controller that works both with keyboard and mouse. There is one other thing we forgot actually. So if I just press play, actually let's set this when we're not in play mode for once. But yeah, if I press play, I won't touch the mouse at all, but you will notice the camera is slowly drifting up. Yeah, that's because on a joystick there's a dead zone. So the joystick won't always be in the exact center, and over like with use and over the time, basically the dead zone gets worse and worse, and that stick won't always be in the center. So here it's set to 0 because on a mouse, if you're not touching the mouse, it's not moving. But we do want to set like something like 0.1. So we'll just set that. We just set that for our actual mouse, which is something you need to remember, that our joystick and our mouse have the same name. So we'll just set our dead zones. And now if we press play, you'll see it doesn't move at all because we've put in that zone to say, yeah, don't move if you're here. Although, because our sensitivity and our dead zone is the same, we're actually just nullifying everything. So let's just try this instead. Because yeah, we're basically just cancelling out any input. And yeah, now it moves, and if you don't touch anything, it doesn't move anywhere. Cool. So you obviously want to play around with things like the sensitivity and the rigid body to get the feel that you want. Feel is really important when it comes to character controllers, but with this system, you have enough ability to control everything, so you can do whatever you want. Yeah, I hope this was helpful. If you have any questions, just leave it in the comments. If there's any other things you'd like to see, yeah, just leave a suggestion and I'll try and make a tutorial on it in the future. And yeah, thank you for watching. Please consider subscribing. And yeah, I just said and yeah a lot.